All right, here we're going to look at section 7.1, looking at identities. So I kind of just wrote a couple statements down here, but maybe I'll start with, even before I look at these statements, because these are really interested in identities, which we're going to get to right down here. So maybe even before I look at these statements, I'll look at this example where I'm simplifying an expression. So this we've actually done a lot of before. All we're really doing here is we're taking each of these expressions and we're saying, well, how could I simplify something like secant x over cosecant x? So as soon as I see that, I think the first thing I would try is I would try using the definition. So writing secant and cosecant in terms of cosine and sine. So then top fraction stays the same, bottom fraction flips. So this one turns out nice. Sine x over cosine x is just tangent x. So I was able to simplify that nicely. So first idea was, well, writing in terms of sine and cosine. So my second thought then, what about something like number 2? So with something like number 2, what I notice is that I actually have a common factor, a GCF, that I can take out of both of these terms. So that would be a cosine x, right? So then what would I be left with? A cosine squared x plus a sine squared x. Oh, and then I know this guy, that's my fundamental identity, right? That's just 1. So actually, I just have cosine x times 1. So my idea with that one was try the GCF. Okay, what about number 3? So again, I'm noticing I have 2 trig functions here that I can write in terms of sine and cosine. So let me try that. All right. Now I have a couple options. I could, if I can get a different color, I could actually find an LCD here, combine those, then take this guy, flip and multiply. That's kind of the longer option. So my other thought is, well, remember again, what I could do is I could multiply this whole fraction, top and bottom, by the LCD. Okay, so let's see if I do that, how this is gonna look. So what's gonna happen here is, I'm gonna take this cosine and I'm gonna distribute it to both terms in the numerator. So what will that give me? That'll give me a 1 minus a cosine squared over a sine x. Okay, right? Because on the bottom here, this is going to cancel with that. Okay, so what next? So actually, there's something special about 1 minus cosine squared. So let me come off to the side here. So think about this. Here's my fundamental identity, right? I know cosine squared plus sine squared x is 1. So wouldn't it be true then that, say, cosine squared would be 1 minus sine squared? And sine squared would be 1 minus cosine squared? So you see, in this one, isn't this, I'm trying to get the highlighter, isn't this what I have up here? 1 minus cosine squared? So can't I can't I replace 1 minus cosine squared then with sine squared? So then my result is just going to be sine of x. So what I'm doing over here, I'm kind of writing out, these are just some properties or facts that are going to be useful. Okay, so what about number 4? So this one's kind of interesting because I actually have these negative arguments. So whenever I see those negative arguments, I'm kind of thinking, well, I wonder if I could come up with a couple of additional properties over here. Just thinking of what would happen if I had a negative argument for cosine, sine, or tangent. And then we'll look back at that problem. But actually, this is pretty easy to come up with because I'm just going to think about the unit circle for a second. So say I have a positive angle theta versus the same negative angle theta. So what do you notice about each of those terminal points? Well, the x is the same at each of those, right? So wouldn't it be true then that cosine of negative theta is the same as cosine of positive theta? Versus you see how if I have a y up here, down here, that y would be negative, right? So for a positive angle versus a negative angle, the sign is opposite, right? Okay, now tangent's easy. Tangent is sine over cosine. So I would have one negative and one positive, so it'd be negative, right? Erased more than I wanted to, be negative, okay? So those are a couple more properties that I can use. So when I come back up to number 4 here, I go, okay, well, let's see, I have tan theta. Then I know cosine of negative theta is the same as cosine of positive theta versus tangent of negative theta is negative of tangent theta. So then actually it can cancel. So it looks like that one is just cosine of theta. So that turns out nice. Clean that up a little bit. So then down here, I'm looking now at proving identity. So you see how here I actually have 2 sides. So I know the answer. So I know that this expression on the left side here is equal to 1. I have to show that that is true. So I am not solving the equation for x. That is not what I'm doing here. Instead, I'm trying to prove the identity. So this is where I kind of wrote out a couple statements up at the top, so you can put these in your notes. So let me go back up to the top of this guy. So I prove an identity by manipulating one side, so taking one side of the identity and trying to make that look like the other side, okay? Now, occasionally I may manipulate both sides to show that they're equal, but I never move things from one side to another, okay? That's what I would do if I were solving an equation. That's not what I'm doing here. Because the idea with an identity is to assume that I don't know the 2 sides are equal and prove that they are, okay? So if you look back down here, all right, so first I pick a side that looks like a side I can manipulate. So in this case, the left-hand side looks like the side that I can manipulate. Okay, so I'm going to take that left-hand side and I'm going to say, what can I do with that left-hand side? Well, what I see, well, I could start by using the definitions to write, say, cotangent and secant and cosecant in terms of sine and cosine. So notice I'm only using one side, the left side. Okay, so what is this? This is cosine over sine times cosine. Okay, what do I want to do with that one? So here, this fraction, what if I take that fraction and I go ahead and flip and multiply? Okay, so then what is that? Then let's see what I can cancel. So it looks like I can cancel a sine with a sine. So what do I have then? A cosine. Oh, look at that. I have a cosine over a cosine. So that is 1. So you see, I've shown that the left-hand side here is equal to the right-hand side. So I have achieved my goal. So I'm going to give this a check. I have proven that that is a true identity. And again, I only used one side in order to do that proof. Okay, so again with number 2, so first thing I do is I pick a side that looks like a side I can do more with. So again, that would be the left-hand side for this one. And then I have a few ideas. So generally with these, you can kind of do them multiple ways. So usually, I mean, there are going to be several ways that arrive you to with the correct, take you to the correct conclusion. But maybe one is less steps than another. But I kind of just have to try things. If I get stuck, I can go back, start over, and try something else. So I don't know. I'm looking at the left-hand side. I guess I'll try something. I'll try writing cosecant as 1 over sine. And then whenever I see this negative argument, I really think right away, I'm going to use one of my properties from up here, right? So I used that guy. Okay, what next? Well, I had different ideas again. I could, I guess, distribute. That's a thought. Or I'm kind of thinking, well, what if I actually combine those two things inside the parentheses using an LCD? So if I'm going to do that, then let's see. Then I have to multiply this guy by sine x over sine x. And so where does that take me? So then I have my 1 over sine x in front. I have my 1 over sine x here. And then I'm going to have sine squared x over sine x. So now I have an LCD inside the parentheses. So I'm going to go ahead and write that as one fraction. So again, now I recognize I have a special identity, this guy. Remember, 1 minus sine squared is cosine squared. So what do I have here then? I have 1 over sine, and then 1 minus sine squared turns into cosine squared. Multiply straight across. Cosine squared over sine squared. Well, that's cosine x over sine x, quantity squared, right? So that's cotangent squared. Okay, look back up here. Indeed, that was my right-hand side. So I'm going to give that a check mark. I have proven that identity. Okay, what about number 3? So I have to make a decision. I mean, this guy, I see a higher power on the left-hand side. So it seems like maybe I can do more with that. And then I'm noticing that Let's see. I have power 4 here, power 2 here. So what if I take that left-hand side and I say maybe, let's see, isn't that sine x plus cosine x squared? Squared again? I'm just kind of thinking of a way to get that second power from that fourth power. So what if I take that left-hand side and instead of power 4, I think of that as a squared squared? Okay, well, let me come off to the side here, side work. So what is sine x plus cosine x squared? Well, that's sine x plus cosine x times itself, right? FOIL. So what is that? It's a sine squared. Let's see, then 2 sine x cosine x, and then plus a cosine squared. Okay, so then I FOILed out the middle part here, and I got what? Sine squared plus 2 sine cosine plus cosine squared. And then all of that is still squared, right? Okay, that was doing a FOIL. And then look at that expression in the parentheses there. Look, see how I have a sine squared plus a cosine squared? So I recognize a special identity there. Isn't that 1 sine squared plus cosine squared? Gonna look like that, isn't it? Oh, well, look at that. There's my right-hand side. So I've proven that identity as well. And so what else do we have? Okay, what about something like a number 4? So with number 4, I would say in this case, the right-hand side looks like it has more that I can do with it. So the right-hand side, let's see. So I think I would try an LCD. So I guess my first fraction, I would need to multiply it by 1 minus cosine x, top and bottom, just multiplying, of course, by 1. My second fraction here, I would multiply it by sine x over sine x. So what am I doing there? I'm doing an LCD. Okay, so then I have 1 minus cosine x quantity squared plus sine squared. And then now this is all over LCD. Okay, and then again, I think I would FOIL. So you see how, again, this is similar to that last problem. 1 minus cosine x squared is 1 minus cosine x times 1 minus cosine x. Let's see, that'd be 1 minus 2. Let's see, 1 minus a cosine minus another cosine plus a cosine squared. Did I get that right? So look up here. 1 minus 2 cosine plus cosine squared plus sine squared over that LCD. Okay, what do I notice? So look at that. Cosine squared plus sine squared again. So that turns into a 1. So what is that? A 2 minus a 2 cosine over a sine, 1 minus a cosine. I see a GCF of 2. Factor that out. Cancel. 2 over sine x. So isn't that 2 times 1 over sine? Isn't that 2 cosecant? And let's see, was that my left-hand side? Indeed. So I've proven the identity there. So shall we look at one more? Number 5. Okay, so what can I do with that one? So I'm thinking left-hand side has that exponent. I think I would try that side. Let me see. So that's a 2. That look a little nicer. This guy's exponent is a 2. Okay. Okay, so let me see what I can do with that. Okay, well, what am I thinking? I'm thinking, let me think of, all right, let's try writing secant as 1 over cosine. Tangent as sine over cosine. You kind of just have to try something. Again, try it. If you get stuck, go back and do something different. So I guess I already have an LCD with that, don't I? So those are both over cosine. Something like that. Okay, let me think about, what if I distribute that squared top and bottom? 1 minus sine squared. And then cosine squared. So I'm kind of just looking up here and I'm looking, at my right-hand side. This is my goal, right? Okay, so you see how on the right-hand side here, everything's in terms of sine. So I'm looking at my latest step and I'm thinking, well, my numerator kind of looks good. What about my denominator? So I'm thinking, well, I wonder if I could replace that cosine squared using that identity, because then I'd have everything at least in terms of sine, which is what I need. So let me try that. So should I leave my numerator as it is for the moment? So 2. Okay, now look at this. 1 minus sine squared. That's a special identity, isn't it? Isn't this called a difference of squares? Compare it with something simple. 1 minus u squared. Isn't that 1 plus u, 1 minus u? In other words, can't I actually factor the denominator here as 1 plus sine x, 1 minus sine x? Oh, look at this. So now, look, I can cancel this with one of those. So then I'll be left with 1 minus sine x to the power 1 in the numerator, 1 plus sine x in the denominator. Oh, and look at that. There's my right-hand side. So I have proven the identity and I'm done. So again, with these, you need lots of practice, because you have to kind of be able to go through them quickly and you have to be able to recognize what little trick or identity you should use at each step. So I suggest you do extra problems from 7.1 in the textbook. Check your answers in the back of the textbook. It has the steps even. This section, you really just have to do a whole bunch of problems until you can kind of go through them quickly.